Everyone. Today we're going to see about semi-supervised learning. What is semi-supervised learning? Why we need these topics? Actually, we have that semi-supervised learning in the form of an branch of machine learning that combines the supervised learning and unsupervised learnings by both labeled and unlabeled data to train an artificial intelligence model for classifications and regressions tasks. So, what is the meaning of an semi-supervised learning? So, we know that we have different types of data. So, as you know that we have data as in the form of text, image, audio, video, like this. So here we will be, if you having the labels data, we will be considered as in the form of an supervised learning. If you don't have the label, that is an unlabeled, we will call as unsupervised learning. So in between, if we have both labeled data as well as an unlabeled, we will calling as semi-supervised learning. So this is the topic. So, though yes, semi-supervised learning is in general employed for the same use case in which one might otherwise use a supervised learning methods. It distinguished by various techniques that incorporate the unlabeled data into a model training. In addition to the labeled data required for the convolutions supervised learning. Semi-supervised learning is a machine learning techniques that uses small amount of data of an labeled data. So we have a small amount of labeled data and large amount of unsupervised, unlabeled data to a trained model. It lies between a supervised learning, that is a fully labeled data, unsupervised learnings, there are no labels at all. So what is the key idea here? Labeling the data is expensive and time consuming, but unlabeled data is abundant. The semi-supervised learnings leverage the both. Okay, this will be calling as an semi-supervised learning, right? So how it is working on? So this is a workflow of an semi-supervised learning. So we know this. This is an label data like cat and dog. We will be label the data, and we don't know the data. Okay, we don't know about the data. Then we have like this. We are calling as an unlabeled data. Here we'll be combine this two for the initial model training. Then we'll go for the predict the unlabeled data. Then we'll with the help of an predictions we'll go for an pseudo of label. So we'll be label the unlabeled data with the help of this. Then we'll go for the retrain the model. Again we go for the model improvement. Again I will go back and we'll check the label or an unlabeled. So this is the workflow of an semi-supervised learning. So let us compare with other supervised learning, how the semi-supervised learnings differ from other types. So first we know the supervised learnings. It is an only label data, and goal of this is for the predictions. And when it is the best, the plenty of label data available. What is an unsupervised learning? Only unlabeled data find the patterns and clusters. No label at all. Just discover the group. In semi-supervised learning, we have the small label data, large unlabeled data, predicted labeled accurately. Labeling is costly, and but raw data is cheap. We have one more type we are calling as in self-supervised learning. That is only for unlabeled and creates its own label from the data. Learn representation first, then we pre-train the steps. So in example, we have a large language model. Okay, so self-supervised learning will be considered as a large language model. So these are the comparisons for the between the semi-supervised learning. Why it is important? So it reduces the labeling cost, improves the model accuracies, useful in real world scenarios where the labeling is difficult. Example, medical images diagnosis. So where we are using these medical images, suppose we have to test for the text data. So if I have only for the text data, I will have text data for the supervised learning. If I having for the image data, for examples, I have an image data of chest images. Okay, now I have to combine this both for the predictions. I have to combine the text as well as an unsupervised learning. Learnings, then you have to go for the semi-supervised learning. For this, we are calling as medical image diagnosis. Then we'll go for the speech recognition, text classifications, and fraud detections. So this is why we need of semi-supervised learning. Example of this learning is, imagine that you have 100,000 emails. Only 50 emails are labeled as spam or not. Remaining 950s are unlabeled. Instead of ignoring the 950 labels, the semi-supervised learnings will learn the pattern from the 50 labeled emails, use those patterns to predict the labels for the rest, and improve the itself iteratively. The core concepts behind it: semi-supervised learning assumes similar data points belongs to the same classes, data forms the clusters, and decision boundaries should be lies in low density regions. So these are the some core concept of an semi-supervised learning, right? So here we'll use the key assumptions of an semi-supervised learning relies on. So it is a smart guess about the unlabeled data using the common assumptions. We'll use the cluster assumptions, smooth assumptions, low density assumptions, manifold assumptions, and these are the some assumption will be done with the help of this semi-supervised learning. Here you go for this cluster assumptions. The similar data points close together usually belongs to the same class. If two photos look similar, they are probably both cats. Smoothness assumption: points that are close in the input space should have similar labels. So nearby points in a future map should get the same labels. Low density assumptions: the boundary between the class should go through areas with a few data points, that is we are calling this low density. Don't put the decision lines where the lot of points are crowded. Manifold assumptions: data lines on the low dimensional surface in a high dimensional space, like unfolding a crumpled papers, helps the relief of the true structures. These assumptions let the model fill the blanks intelligently. So this is a process of an key assumption of an semi-supervised learning. We have the common techniques in semi-supervised learning. One is an transduce and introduce. So what is this meaning of this transit method is label the propagations. So we use the graph methods, graph based. All the points are in the form of a node in the graph, edges weighted by the similarity. Label the spreads from the labeled to unlabeled points iteratively. So we'll use the smoothness plus cluster assumptions. So here we'll go for the origin points of left pseudocode labels after the propagation. So this one we are calling as label propagation. Next, we have the active learning. So, what is an active learning? This is an smartly choose when which label unlabeled points to the label next. Reduce the labeling needs. Example of labels for the semantic segmentations in studies. So, inductive methods, we have wrapper method. We have the self training and co training, and we have that unsupervised pre-processing, intrinsically semi-supervised method. So what is it mean by self-training? The self-training is an label, predict on the unlabels, add the high confidence pseudocodes that is in above 50, 85% sure, and retain. Repeat after this completions. Again, you have to go for the repeats. Use the entropy minimizations to avoid the bad pseudocode labels. Code trains. So what is the code trains? So, train the multiple models on the different view subsets of an data. They teach each other with an confidence predictions. Next, we have this unsupervised pre-processing. We have the cluster, then label. Cluster all the data first, like with the help of an DB scan. Then use the cluster to guide the labeling of an or labeling or training. So, what is pre-trained and features extractions? Use the autoencoder to learn the better representations with the help of an manifold assumptions. Then fine-tune the supervised learning. So, these are the techniques for the unsupervised learning. So, intersectly semi-supervised learning, that is we are considered as three ways, right? Like an semi-supervised support vector machines, extended of an semi-subto to pencilize points in the margin. That is a low density assumption. We use the low density assumptions. We have deep learning variants, modify the loss functions with the help of ladder networks, temporarily enabling and GAN based. So these are the methods, and we have the common techniques in semi-supervised learning. What are the popular simple techniques in semi-supervised learning? There are self-training. So this one we are calling as pseudo labeling. They train a model on a low label data sets. Use it for the prediction labels on the unlabeled data sets. Creates the pseudo labels. Only keep the high confidence of an above 90 percentage or an 85 percentage. Add those confidence of pseudo label helps back to training. So retain, repeat a few minutes, simple work and with a any classifier. Example. So we have seen this, right? We have 100 label emails, but I have 10,000 unlabeled. So unlabeled emails, the model predicts on unlabeled of ads for 4,000 conference ones, retains accuracies jump from 78 to 91 percentages. Then label propagations or label spreading, treat all the data label and unlabeled as a point on the graph, connect the similar points with the edges. Propagates means known the labels from the labeled points to nearby unlabeled ones, like spreading ink on paper. Iteratively smooth the label across the graph, great when data has natural clusters or smooth regions. Visual ideas will be like an imagine dot on a paper. A few are colored in red and blue, like you're calling as labeled. Color spreads to close uncolored dots until everything is colored smoothly. So this one we are calling as label propagations. What is code train? The user do different views of the same data, like an text and image or two features of sets. They train the two models each on one view. They teach each other the confidence predictions from one becomes a label for the others. They reduce the mistakes because errors in one view are corrected by others. Example, video classifications. One model uses the visual frames, another uses for the audio and subtitles. This we are calling as co-train methods. We have the other methods. We are like, so the modern deep learning affairs, and we'll have the graph-based models. Data is represented as a graph with the nodes and edges. Labels are propagated from the label nodes and unlabeled ones graph. So we have the real-time problem world examples and applications. We'll go for the medical imagings. The few doctors and label the X-ray images plus thousands of unlabeled scans, better for the tomb detections. Image classifications and object detections, labeling the every pixel is hard. So semi-suppressed learning helps the segment the car and people, etc. Drug discovery and genetics, except the labeling is slow. Expert labeling is slow. Use semi-suppressed learnings on a protein sequence or chemical structures. Web text classifications, few label pages plus millions crawled classifications, topics or segmentations. We have large language model. It is a pre-trained supervised unsupervised learnings, and we have the self-supervised learning. It is used for the fine tunes with the help of a bit of label data. We have the advantages: saves a huge labeling cost time, better performance than supervised only with few labels, improves the generalizations, works with many basis model like SVM neural nets. What are the challenges? If the assumptions does not hold, then it is can hurt the performance. Risk of confirmation bias, model reinforce into its own wrong pseudo labels. Needs careful tunings because it is an assumption have to done. So needs careful tuning. Same. Is carefully, not magics. This approach is widely used today because most real datasets are exactly like this. Summary. So semi-supervised learning is a smart way to sequence the more performance out of expensive data, labeled data by letting the model safely learn from the cheap unlabeled data. Thank you for listening and subscribe my channel.